Hello guys, this is the Med Dude and today we're doing Edexcel P3 October 2021. So let's go right to it. So question number 1. The function f is defined by f of x is 5x over x squared plus 7x plus 12 plus 5x over x plus 4. Show that f of x equals 5x over x plus 3. So in this situation, you can always tell that we need to factorize this expression here. So factorize this. So let's do that first. So x squared plus 7x plus 12. So immediately I always think that this has to be a factor, so it can cancel out. So I'm just going to put x plus 4 here. And then you're left with, so 4 times 3 is 12, so x plus 3. So that's how we have simplified this. So part A over here. So f of x equals 5x, so all over x plus 4 and x plus 3 plus 5x over x plus 4. So now we want to make the common denominator, so we have to times this term by x plus 3 both bottom and top. So that will result in f of x equals 5x plus 5x x plus 3 all over x plus 4 x plus 3. So that will be, so we can expand the bracket, so that will be 5x squared plus 15x plus 5x all over x plus 4 x plus 3. So that'll be 5x squared plus 20x and x plus 4 x plus 3. And then we can simplify this by taking 5x as a common factor. 5x x plus 4, and this will be x plus 4 x plus 3. And you can see here we can cancel out x plus 4 and x plus 4. So we're left with f of x is equal to 5x over x plus 3. So I'll just write the file. So that's how we get f of x. So show that f of x equals 5x x plus 3. That's how we show it. So part B, find f inverse. Now the key thing here is that we swap the variables, right? So the key thing here is we swap this f of x with y and f of x with x and x with y. And then we try to find what y is. So let's see. So we have part B. So I usually do is I swap the variable. So this becomes x equals 5y over y plus 3. So now we can put it on the side, x plus y plus 3 equals 5y. Then it's xy plus 3x equals 5y, and then let's take the 3x as it is, so we take xy to the other side, 5y minus xy, so then we get 3x equals, so take y as a common, so y equals 5 minus x, so our y equals 3x over 5 minus x, so our f inverse x is 3x 5 minus x. Now are we done here? We're not, because we also need to state its domain, because you can see over here that they have stated its domain here in the beginning of the function. We should always state the domain when we have f inverse. So the domain will be what? So let's see, that's where, so we know that it has to be greater than 0, so that's for sure, right? We know that. So the domain will be, so it's already 0 is greater than x, right? And we can see the denominator cannot be 0, right? So the denominator 0 is when it's 5, so x has to be less than 5. So our domain will be, domain will be 0, x is greater than 0, which n is less than 5. So our final answer is domain and the f inverse function. Alright, so let's go to part C. So part C says, find in the simplest form the first differential of x. That's pretty easy. Then we have to state whether f is an increasing or a decreasing function, giving the reason for your answer. Alright, so we have f of x, so I'm going to go down, so we'll just write it here. So c I, so we have f of x is 5x over x plus 3, right? And we know that we can use the quotient rule. So y equals u over v, and then if we were to differentiate this dy over dx, we will get what? We will get v du over dx, take away u dv over dx, and this is all over v squared. So now let's put our terms. So u we know is 5x and v equals x plus 3. So when you differentiate 5x, we get 5. Differentiate v, we get 1. Because we only have x, so that'll be 1. Right? So now we can do that. So now we can turn to our differentiation of x will be, so we take the combination, so that'll be 5, so v will be x for 5, x plus 3, minus, so u, which is 5x, times 1, which is 1, all over x plus 3 whole squared. Let's simplify this, so that'll be 5x plus 15 minus 5x x plus 3 whole squared. So this will now result in 15 over x plus 3 squared. So we can just run this f, or for differentiation of x, will be 15 over x plus 3 squared. So that's our final answer for part I. Now what did part I say? Part I said, determine whether, so it says hence as well, so we need to look at our first answer to this, right? So hence say whether f is an increasing or decreasing function, giving a reason for your answer. So we can do that. So part I. So we know that f of f, the first differentiation of x. Now is this less than 0 or greater than 0? For any integer of x, right? This is a squared value, so it'll all be greater than 0, right? And because our differentiation is always greater than 0, that means f of x, right? F of x is an increasing function. How do we prove this? We can also say because you can see the denominator here, right? You can see the denominator here, x plus 3 squared, it's always positive for any value of x. So we can just say because x plus 3 whole squared is always positive. So the gradient is always positive. It's never negative. So it's never decreasing. So it's always positive. So yeah, that's the reason why f of x is greater than 0. And then you can say it's an increasing function because x plus 3 whole squared in the denominator is always positive. So hence the whole function is always greater than 0. Right, moving on to question number 2. So figure 1 shows a sketch of the graph with the equation y equals f of x, where f of x equals 3x minus 3 absolute of that plus 5. So the vertex of the graph is at point P. So this is point P. As shown in figure 1, state the coordinate of P. Okay, so if we were to imagine this without the translation, so this is basically a translation of 5 upwards, right? If without the translation, this P would be on the x-axis, right? And because of that, we can just imagine this as 0. We can just take this and say 3x minus 13, what if it was equivalent to 0? So that will be 3x equals 13. So x equals 13 over 3. So what we have done with the plus 5 is just translated this x-intercept upwards. So our final answer for P will be 13 over 3, 5, because this is where it meets the x-intercept. Okay, so now it says BI says state the range of f. Now BI, let's look at that. So you can see over here that This is y equals 5, right? Because we have translated 5 upwards. So all the values are always above this point. So we can say the range of f, right? So we can say the range of f is f of x is always greater than 5. Greater than or equal to 5. So this is the answer for this, and this is the point for this. Then it says, find the value of f of 4. So I'm just going to write b I here. So we want f of, I do it in brackets so we know f of 4. So let's do that. So what's f of 4? We can just substitute that. So that will be, I'll just do it in the bracket. So that will be 3 times 4 minus 13, absolute of that, plus 5. Okay, so what's this? So this is 12, right? This is 12 minus 13, which is equal to negative 1. The absolute of that will be 1. So we're left with f of 6. And that's pretty simple. All we have to do is now substitute 6. So that will be 3 times 6 minus 13 plus 5. So that's 18 minus 13, which is 5. And then 5 plus 5 is 10. So we can write, so f of 4 is equivalent to 10. So we can just do this. That is our final answer for this. Next we have part C. Part C is solve using algebra showing you're working for this equation here. So 16 minus 2x is greater than absolute value of 13x minus 13 plus 5. Okay, that's pretty simple. So I'm just going to do it here. I'm going to C here. So C. So we can solve it in two ways. So we have to solve it to 16 minus 2x. So 3x minus 13 plus 5. Now this can be split up into two sections. We can say a negative 1 and a positive 1. So we can say it's either plus 3x minus 13, or we can say it's negative 3x minus 13 when we multiply it. So let's do that. So let's move down a bit and we can write, so 16 minus 2x is less than, so we're going to go to the positive one first. So that will be 3x minus 13 plus 5, and we'll do the other side simultaneously. 16 minus 2x is greater than, so now we are multiplying the brackets for minus 3x and minus 13, so we'll get minus 3x plus 13 plus 5, right? So now we're only dealing with algebra. It's pretty easy. So we can just say 16 minus 2x. So we can just say 16 minus 2x greater than 3x minus 8, right? We can move the 2x on this side and 8 on the other side. This becomes 24. This becomes 5x. So x is greater than 24 over 5. So that's very simple here. Next, on the other side, we have, so 16 minus 2x is greater than minus 3x plus 18. We move this 3x minus 3x to the other side, becomes x is greater than, so 18 minus 16 is 2. So this is what we're left with. So we can say, so this is also important to say, we need to mention critical values, which are x, so which are, the critical values are 2 and 24 over 5. So you can see that we have a range here, so we know that x is greater than 2, but it's also less than 24 over 5. That doesn't look like an x, so that's, here we go, x, 24 over 5. So our final answer for this question is 2, this is the final answer for this question. When we solve it, this is the final answer. Okay, so now let's look at D. So they're telling us that graph with the equation y equals f of x is transformed onto the graph with y equals a f of x plus b. So we know this is a scaling factor. This is a scaling factor. So it affects the y values. So y values are affected. We're multiplying them. And x plus b, that means we're shifting it. So this is a shift. This is only a shift such as translation left or right. Shift either left or right. Okay. Depending on what b is. So they're saying the vertex of the graph with y equals is now 420. So before it was what? Before P it was 13 over 3, and this was 5. So given the a and b are constant, find the value of a and b. So we can see, let's look at the y values. So you can see over here that we have 20 in this one, and then we have 5 in the original one. So it's been scaled up 4 times. So we can say a equals, so we'll write 20 over 5 equals 4. So we can say, so a equals 4. That's one of our answers. Scaling factor of 4. I'll just write part D here. Okay. And for B, let's look at B. There's a shift, right? So all we have to do, so for B, all we have to do is the shift, isn't it? So all we have to do is take 13 over 3 and let's take away 4. So that'll be the original shift. So 13 over 3, take away 4. So that's 16. So that is 12. Yeah, 12 over 3. That'll be 1 over 3. So our final answer is B, the third. So our final answer is A equals 4 and B equals a third. Alright, so now moving on to question number 3. Alright, so we've been given a graph. So figure 2, the total mass of gold in G tons extracted from a mine is modeled by the equation G equals 4t minus 30 e to the power of 1 minus 0.05 t, where t is greater than k, G equals 0, where t is the number of years after 1st January 1800. Figure 2 shows the sketch against t. Okay, we saw that. I could use the equation to our parts A, B, C. Okay. Find the value of k. Now you can see here k is the x-intercept, right? Now what does that mean? The x-intercept means that it's what? This is when y equals 0. In this case, when g equals 0, right? So we can go down and let's look at here. So AI. So let's look at the equation again. So the equation is g equals 40 minus 30 e to the power of 1 minus 0.05 t. Alright, so now we know. So we can now equate it to 0, right? So 0 equals 40 minus 30 e to the power of 1 minus 0.05 t. Move 30 to the other side. So this becomes 30 e to the power of 1 minus 0.05 t equals 40. Then we can divide both sides by 30. It'll simplify. So e 1 minus 0.05 t equals 4 over 3. Now to get rid of the e, we have to ln both sides. Natural ln both sides. So when we do that, there'll be ln e 1 minus 0.05 t equals ln 4 over 3. Then it's pretty simple. All we have to do now is the ln e cancel out, so we're left with 1 minus 0.05 t equals ln 4 over 3. Then we can simplify even further. We can move the t on this side and ln on the other side. This becomes 1 minus ln 4 over 3 equals 0.05 t. So t equals 0.05 t. So this will be 1 minus ln. That's not, is this t? Or yeah, we are talking about t. So ln 4 over 3 all over 0.05. So when we put this in the calculator, we will get, so t equals in this case 14.245 or 14.25 is also fine. We can also round it to t equals 14.25. That's our final answer. Both answers are correct. So that means k is not not t, k, because at the end we have k, because that is our x-intercept. So k. All right. So that's our final answer. So let's look at part II. Hence find the year and month in which the gold started being extracted from the mine. So all we have to do is add 14.25 years to first. So 1840. So we have to add 14.25 years to 1800s. It's first Jan, right? First Jan. So when you add 14, that'll be 1814.25. So that'll be that many years in total. Now 0.25 of a year means, so times by 12 months in a year, that'll be third month, which is March. So final answer will be March 1814. So that's our final answer here. So this is part II. Alright, so let's look at the next part. So find the total mass of gold extracted from the mine up to 1st January 1870. That's pretty easy. So that means that, it's part B, 1870 means what? That means T equals 70. So all we have to do is substitute, right? So we remember, so it's G equals 40 minus 30 e to the power of 1 minus 0.05 times 70. Alright, so G will be, so this is 37.5. So 37.5 tons. So that's our final answer. All you have to substitute, it's only 2 marks. So this is sufficient working out. Let's look at part C. So what does part C say? Part C says, there's a limit to the mass of gold that can be extracted from the mine. State the value of this limit. Now this is pretty easy if you think about it. If this part is 0, if this is equivalent to 0, what's the maximum that you can do? What's the maximum tons you can have? It's 40. That's what you started with. It's 40 takeaway, right? So our max limit, right? So our max slash limit will be 40. And because it's 1 mark, so it's fine. So we can just say G cannot exceed 40. So G cannot exceed 40. So that's that. So we can just write this as the answer. Maximum will be 40. G cannot exceed 40. Alright, so now let's move on to question number 4. So we have, in this question, we have, show that the equation 2 sine theta minus 30 is equal to 5 cos theta can be written as tan theta equals 2 root 3. Okay, so in order for us to expand this, we need to remember that sine A plus B is equivalent to what? It is sine A cos B plus cos A sine B, or sine A sine B cos A, same thing. So let's do that. So let's expand. So part A. These questions are quite lengthy because of the proof questions. It's okay. So 2. This will be sine theta cos 30 minus, so sine 30 cos theta equals 5 cos theta. Now cos 30 is root 3 over 2, so 2, so this is sine theta multiplied by root 3 over 2 minus, so sine 30 is a half cos theta equals 5 cos theta. Now we can multiply everything by 2, so that will be root 3 sine theta minus cos theta equals 5 cos theta. Okay, move the cos to the other side, becomes root 3 sine theta equals 6 cos theta. Now because we want tan, we have to divide both sides by cos, so that'll be root 3 tan theta equals 6, and then tan theta equals 6 over root 3. So let's rationalize 6 root 3. So 6 over root 3 times by root 3 over root 3. You're left with 6 root 3 over 3. 6 and 6 divided by 3 is 2. So 2 root 3. So our final answer is, so we can do it underneath it. So tan theta equals 2 root 3, and that is how we have shown in this form. Alright, let's move on. Hence or otherwise, that means we have to use this from before. That's pretty convenient. Solve from s0 less than x less than 360. Okay, that's fine. And it's a similar, so we have, this is our, so if we imagine this is our theta minus 30, and this is our theta, does that work? Let's see. So if x plus 20, take away 30, this gives us x minus 10. So this does work in this case, right? So this is theta minus 30. This is theta minus 30, and this is our theta, right? Yeah, it does work. So we can apply the same thing. So that's pretty simple. So all we have to do now is part B here. So this will be equivalent to tan of x plus 20 equals 2 root 3. Okay, and because we've done that, our range also changes. This becomes 20 greater than equal to x greater than equal to 380. This is x plus 20, obviously. Let me just rewrite this. X plus 20. X plus 20 is then 380. Alright, so now let's do that. So let's tan inverse. So x plus 20 equals tan inverse of 2 root 3. And what do we get when we do tan inverse of 2 root 3? So we get 73.9. And is that the only solution? I don't think so. Let's find out. So let's draw the CAS diagram. This always helps. So this is CAS, so C, A, S, and T. So our 73.9 is around here. So this is our 73.9 degrees, 0.9 degrees. And when is it positive again? It is, tan's positive again is here. So that's, we add another 180 degrees. So it's 180 plus, so this is 180 plus 73.9. And that gives us 253.9. So our other solution over here is 253.9. So our range is 380. Does it come back? I don't think so, because 360. So we'll just check. So 360 plus 73.9 is 430.9, and that's greater than our range. So we ignore that. So our answers will be. So x plus 20 equals 73.9 degrees, 253.9 degrees. So x equals, so take away 20, so that's 53.9. And that's 233.9. So our final answer are these. Alright, so let's move on to question number 5. So question number 5. Okay, so 5i. By algebraic integration, find the exact value of integration of 8 over 2x minus 3 cubed, where we have the limits 4 and 2. Okay, so we can do that. So so for this, we can do integration by substitution. So 2 and 4, 8 over 2x minus 3 whole cubed dx. So let's do integration by substitution. So how do you do that? We take u as our 2x minus 3. We take u as our 2x minus 3 in the denominator. So 2x minus 3. We differentiate this, 2 du over dx. We get 2. And then now we make dx the subject, because we have to substitute it back in. So that will be so dx equals du over 2. Right? You can see that it goes here and then 2 goes down. Pretty straightforward. So that's our first key component. And our second key component is we also have to change the limits. Right? So first limit was 4. So now this will be so u will be, the limit will be 2 times 4 minus 3. So that's 8 minus 3, which is 5. The next limit will be, so u equals 2 times 2 minus 3. So that's 4 minus 3, which is 1. So these are our new limits. that we have to use. Okay, so let's simplify them now. So let's go back. So that will be, so new limits are 5 and 1 and 8 over u cubed dx. Now dx, we can simplify this to 1, 5, 8 over u cubed times by du over 2. Pretty straightforward. So that will be, so it becomes 4. Let's change it to indices form. That will be 4u to the power of minus 3 du. Now this is pretty straightforward. So this is now, so this is 4 times u to the power of minus 2 over 2, negative 2. And this is 5, 1, which is equivalent to, let's simplify, that will be minus 2 u2, so minus 2. So that's minus 2, 5, minus 2, take away minus 2, so 1 to the power of minus 2. Alright, so that'll be equivalent to, this will be 5 to the power of minus 2 is 1 over 25. That'll be minus 2 over 25. So this is minus 2, and then we add 2, so this will be plus 2. So our final answer will be, 48 over 25. So we can leave it as that. So that is our final answer. Okay, so our next question is, find in the simplest form the integral of x bracket x squared plus 3a to the power of 7. Now this in itself is not that simple. So what we can do is we can take the x, right? We can put it inside. What we can do, put it inside. Not put it inside. We can take this as the same thing. We can use integration by substitution, and we can say u equals x squared plus 3. So let's do that. So if we were to do that again, say, let me, if I was to take this, and then we'll do it here. Alright, so we can just try to remember it then. It's part C. It's the integration of x squared plus 3 to the power 7 dx. Okay, so now we say, so let u equals x squared plus 3. So du over dx is 2x, and then we make dx the subject, so that'll be du over 2x. You can see here that there are no limits, so it doesn't matter. So now all we have to do is now substitute back it in. So this will be x times by u to the power of 7 dx. This will be equivalent to x times u to the power of 7 times du over 2x, right? Because we substituted back it in, right? So this will be, now x will disappear, so you're left with u to the power 7 over 2 du. This is pretty straightforward. So that will be, so this will be half times u to the power 8 over 8 plus c. That will be 1 over 16 u to the power 8 plus c. And then we have to substitute back everything in. So our final answer will be 1 over 16. So u was x squared plus 16, so x squared plus 3 to the power of 8 plus c. So that's our final answer. This is our final answer. Alright, so let's move on to question number 6. Question number 6 says, the curve C1 has the equation y equals 3 ln bracket x squared minus 5 minus 4x squared plus 15, so x is greater than root 5. Show that C1 has a stationary point at x equals root p over 2, where p is a constant to be found. Okay, so let's do that first. So let's just write the equation here. So y equals 3 ln x squared minus 5 minus 4x squared plus 15. Right? X is greater than root 5. So we need to get stationary points. That's when gradient equals 0. So dy over dx. Right? So we know that the differentiation of ln is 1 over x, so this will be 3 over x squared minus 5, but we also timed by the inside of the function, so that's 2x, so it's multiplied by 2x minus 8x. That's pretty simple. So now let us simplify. So this is 0 equals 6x over x squared minus 5 minus 8x. So let's put 8x on the other side. So now let's put 8x on the other side. So that'll be what? That'll be 8x equals 6x over x squared minus 5. And then we can take the denominator to the other side. So it becomes 8x bracket x squared minus 5 equals 6x. That'll be 8x cubed. No, it's 8x. No, it's just 8, sorry. Yeah, it is 8x, yeah. Did I copy it? Yes, I did. It's 8x, yes. Okay, so then you can see over here that both x's can cancel out. So now we're left with 8x squared minus 5 times 8 is 40 equals 6. So now this will be 8x squared equals 46. X squared equals 46 over 8, which x squared equals 23 over 4. And when we square root it, that'll be plus or minus 23 over 4. That'll be plus or minus root 23 over 2. Now we know that x is greater than root 5, so we don't care about the negative value, so x equals root 23 over 2. So that is our stationary point where p is found. So p we know is root 23 over 2. So p is 23. So that's our final answer. Let's look at part II. Part IIA. So I'll just do it here because we have some space. So II part A. So a different curve, C2 has equation y equals 4x minus 12 sine squared x. Show for the curve that dy over dx equals a plus b sine 2x. Okay, so let's see how we can do that. So we have y equals, so let's write, so y equals 4x minus 12 sine squared x, right? So when you differentiate this, so this is 4x, so that's 4. Now we're applying the chain rule to the next one, so that'll be minus 24 sine x, and then we are multiplying we are now differentiating sine x as well, so that'll be cos x. Alright, so that will be 4 minus 24 sine cos x. Now they want it in sine 2x, and if you remember, let's sine 2 theta is equal to 2 sine theta cos theta. So that'll be 4 minus, so let's do this, so it'll be 12 times 2 sine x cos x, right? So that'll be equivalent to 4 minus 12 sine 2x, right? So that's our dy over dx, where a and b, we have found them, so that's our final answer. Let's look at part B. Part B says, hence state the maximum gradient of this curve. So they want the maximum of this, right? So they want dy over dx max. That's what they want, right? So that's when 4 minus 12, when sine 2x is now equivalent to negative 1. That's when it's, because we want plus 12, right? So our maximum gradient, max gradient, equals 4 minus 12, which is 4 plus 12, which is 16. Pretty straightforward. That is our final answer. Alright, so now let's move on to question number 7. Alright, so question number 7. The mass m kg of species of a tree can be modeled by the equation log 10 of m, log base 10 m, 1.93 log base 10 r plus 0.684, where r is the base of the radius. The base of the radius of this particular t is 45. This key information, so r is 45. Okay. Next, according to the model, find the mass of this tree, giving your answer to 2 sig fig. Pretty simple. All you have to do is now just find what m is, because we know r is 45. So part A, log base 10m equals 1.93 log base 10 45, because we know r is equal to 45, plus 0.684. Alright, so the first part is a calculator function. It's pretty straightforward. This is now log base 10m, and so when you put this in the calculator, what do we get? We get 3.8747. That's what we get. And now to convert this into indices form, it now will be m equals 10 to the power of 3.8747, which will be equivalent to 7493 kilograms, but they want it in 2 sig fig, so that will be m equals 7,500 kilograms. Please stay forward. That's our final answer. Alright, now it says show that the equation of this model can be written in the form m equals p times r to the power q, given the value of p and q to the r 3 sig fig. Now they want to convert this into this. You can see that there's logs involved. So what we can do in the beginning, right? So it's part B. In the beginning, we can log both sides. Let's log both sides, and obviously to the base 10. So that'll be log base 10 m equals, so log base 10 p r to the power q. Now we know then when inside the log, when we're multiplying, we're actually adding. So multiplying equal to adding of log, addition of logs. So we can split them up. So this will be log base 10m equals log 10 of p and log base 10 r to the power q. Now we know from the power rule that this q can go down. This is the power rule, that q can be written as beside log base 10r. Alright, so that'll be log of 10m equals, so I'll write q log base 10r plus log base 10p. Now let's look at the initial equation we had, which is this, right? This time hopefully I can copy it properly. Copy, and then I can paste it here. Here we go. So now let's look at what's similar and what's not similar. You can see over here that log base 10 is the same. This is obviously the same, and we can see q is 1.93, and this log base 10p is equivalent to 0.684. So we can write q equals 1.93. and then we can write log base 10p equals 0.684. So p will be, so 10 to the power of 0.684. So that's equivalent to, put in a calculator, you'll get 4.83, and they want to 365, so 4.83. So p is equivalent to 4.83, right? So that's our final answer. So p is this and q is this. Look at part C. So with reference to the model, interpret the value of this constant p. Okay, so we don't have p here, we're only looking at this model here, right? So let's first write the model. So part C. So m equals p to the power of r to the power of q. And we know p in this case is 4.83, right? This is p, and we know that q is 1.93. So let's rewrite this. So there will be m equals 4.83 times r to the power of 1.93. So we know, what do we know about this constant? We know when r is equal to 1, right, the mass will be 4.83, right? So we can just say p is equal to the mass when r equals 1, because we can't have r equals 0, can we? Because if we had m equals 4.83, we want the lowest value of r for what this works if we had r equals 0, right, then mass will be 0, and that's not the case, is it? But we want the initial mass, that's when radius r equals 1, so that's why we take r as 1, so p is equal to the mass when r is equal to 1. That's our initial mass that you start off with, and then as r increases, obviously our m increases as well, based on 4.83. Alright, so that's why. So that's part C, and yeah, that's it. Let's move on to question number 8. So we have the question: a curve C has equation y equals f of x, where f of x is arcsine half x with the range domain -2 less than x is greater than x. So this is the range -2 x2, and this is the range minus pi over 2 y pi over 2. So sketch C. So can I sketch C here? Let's sketch C here. So, and then this is not straight. Alright, so what do we know about arcsine graphs? They sort of look like this. And well, yeah, sort of look like that, but they're more condensed. So in this case, so that'll be they're more like this, and then like that. Alright, so that's our arcsine x half x. So this is our x. So we know that the limits here will be, because there's half x, this will be 2 instead of 1. This will be 2 instead of 1, but the y will stay the same as pi over 2. This is pi over 2, and this is obviously, go back up here too, and this is also minus pi over 2. Minus pi over 2. Alright, so we only get 1 mark for this because we already know, they just want to know the shape of it in sketch. It's not an actual drawing. So that's what this is. Let's look at part B. So part B says, given x equals 2 sin y, show that dy over dx is 1 over a minus x squared, where a is a function we found. So let's do part B here. So we know x equals 2 sin y. To find dy over dx, right, currently we can only find dx over dy, but what we can do is do 1 over that to get dy over dx. So let's do that. So dx over dy is 2 sin y will be now 2 cos y, right? Yeah, that'll be 2 cos y. But do 1 over that, that'll be 1 over, so let's write dy over dx equals, so dx over dy equals 2 cos y. 1 over, sorry, not, that is 1 over, sorry, 1 over 2 cos y. Now because we want to simplify this, right? So we want something square root. We always think of trig identity. So the only trig identity that you can see that relates sine and cos, right? We need a trig identity. Trig identity that relates sine and cos. And the only one that I can think of currently, which is sine squared x plus cos squared x equals 1. Alright, because that's the one that has something minus x squared, right, when we make something the subject. So right now we have cos y, so let's make cos x the subject here. So that'll be, so no, we'll just use y. So cos squared y equals 1 minus sine squared y. So cos y equals 1 minus sine squared y all over, so that's square root. So we can now substitute this back into here. That will be 1 over, let's make it a bit larger, so 2 square root 1 minus sine squared y. Now we know from the initial question, right, we know that x equals 2 sin y. So now we can simplify this, so that will be x over 2 equals sine y. So this whole thing squared will be sine squared y. Right, so that will be x squared over 4 equals sine squared y. We can now substitute this back into here. So that will be 1 over 2 root 1 minus x squared over 4. Now we need to multiply inside this square root everything by 4. So what are we doing? So we have to do the same thing above. So that will be, so we times by root 4 here, and we're timesing by root 4 here, aren't we? Because it's inside the bracket. So inside the root. So that will be, so root 4 is just 2 all over 2 square root of, so when you multiply by 4 we'll get, so this becomes 4, and the fraction is now minus x squared. You can see over here the 2 and 2 cancel, so you're left with 1 over square root of 4 minus x squared. So this is our dy over dx. So our final answer, I'll just write here, dy by dx is 1 all over 4 minus x squared, and that's it. So they wanted what a is, and a is b, sorry, a is 4. So you have done, so that is the final answer. Alright, so let's look at part C. They tell us that the point P lies on C and has a y coordinate of pi over 4. Okay. Then they say find the equation of the tangent to C at P. Right, your answer y equals mx plus C, where we have to find this. The tangent means differentiation and substituting this, right? And that's what this means. So let's do that. So part C. So we know that they're talking about, so we know x equals 2 sine y. And we know that our coordinate that we can input is pi over 4, so 2 sine pi over 4. And don't forget to put it in radians, so this is root 2 over 2, so x equals root 2. So our point P is root 2, and it's pi over 4. Now we have to do what? We have to find the gradient, right? We need to substitute this into, to find gradient. So function, which is dy over dx, and that is equivalent to, so 1 all over 4 minus root 2 squared. That's the same thing as saying 1 over square root of 4 minus 2, so that is 1 over root 2, which is root 2 over 2 when we rationalize it. So that is our gradient m, which is our tangent gradient. So now all we have to do is y minus y1 equals m x minus x1, and that will be, so we know our y coordinates, so y minus pi over 4 plus, minus pi over 4, and then what we have equals to, so our gradient is root 2 over 2 x minus root 2. Okay, that's pretty straightforward. You have to expand, so pi over 4 is 3 that it is. This becomes root 2 over 2x. So now root 2 over 2 minus, times by minus root 2, so that'll be 2 over 2, which is 1. So minus 1. Alright, so our final answer will be y equals root 2 over 2x minus 1 plus pi over 4. We can't simplify it any further, so our final answer for the tangent at P is this. This is our final answer. Alright, let's move on to question number 9. So question number 9 says, figure 3, this is figure 3. Figure sheet shows a sketch of the part of the curve with y equals f of x, where f of x is x bracket x squared minus 4 times e to the power minus a half x. Okay, now this we can simplify because this is not to the power of anything. So what we can say, and we can rewrite this as x cubed minus 4x e to the power of minus a half x. And then we can use the product rule, right? We can use the product rule. So now to remember the product rule, it's this. So that is dy over dx is usually just u dv over dx, right? Plus v du over dx. That's it. So let's look at the variables. So we have u equals x cubed minus 4x. And then when you differentiate this, we'll get 3x squared minus 4 and for v is e to the power of minus a half x. This is very easy. So when you differentiate this becomes, so anything in the power just becomes below, so minus a half e to the power of minus a half x. That's pretty simple. So now let's find what the differentiation of this will be. So that's just we take u and dv over dx. So that will be, so let's make it easier to look, minus a half, that is x cubed minus 4x e to the power of minus a half x, and then we add these two, multiply them and add them, so that will be plus 3x squared minus 4 e to the power of minus a half x. And if I was to write it more neatly, so that will be, so 5 differentiation x, so in one line that will be, so let's take the positive one first, so 3x squared minus 4 e to the power of minus a half x minus 1 over 2 x cubed minus 4x e to the power of minus 1 over 2x. That is our final answer to finding the differentiation. You can see it's only 2 marks, so we don't need that much working out. So if you know the part rule really well, you will not have to do the previous steps. You can go straight into the answer. It's fine. Then it says, what's the next part? It says the line L is the normal, so that's perpendicular to the curve at 0. Means the curve at point P. Point P lies in the third coordinate as shown in figure 3. Let's look at figure 3. This is point P. Show that the x coordinate is the solution of this. Okay, so first, in order for us to do this, we need to first find out the gradient, right? We need to find out the gradient of f of x, right? We need to find the gradient of f of x as, so at 0, we need to find the gradient. And then we have to take the perpendicular of it to find the gradient of line L, right? So let's do that. So let's first do that. So part B. So that'll be what? So finding the gradient at 0 will be differentiation of 0. That's pretty easy. Let's just do that. So that's 0 minus 4. So that'll be minus 4 e to the power of 0, which is just 1, minus a half, and then this is, so x cubed, that's all of this is 0, so that's 0, and then this is also e to the power 0. So we're left with it just minus 4. So the gradient, so the normal gradient will be minus 1 over negative 4, so that will be 1 over 4. So our line L will be y equals 1 over 4x plus c, but you can see over here that they intersected 0, so there is no intercept, so our line L is y equals 1 over 4x. Now we want to find out the intersection between this line L and f of x. So all we have to do is find the intersection by doing this. So L equals f of x, so that'll be quarter x equals, so that is x squared, so x, so we just use the initial equation, that is x squared minus 4 e to the power of minus 1 over 2x. So that is, so you can cross out both x's, so that will be 1 over 4 equals x squared minus 4. Now we can rewrite this, so this is also the same thing as saying e to the power of a half x, because it's minus power. We can now move this to the other side. This will be now e to the power of a half x. Even with the 4 to the other side becomes 4x squared minus 4. So e to the power of a half x is equal to, let's expand the brackets, so that'll be 4x squared minus 16. Now all we have to do is now make x squared the subject, x the subject, sorry. That will be 16 plus e to the power of a half x equals 4x squared. That's the same thing as saying 16 plus e to the power of a half x all over 4 equals x squared. And then we can write, so x equals plus or minus square root 16 plus e to the power of a half x all over 4. Now we know that the square root of 4 is 2, so this can be written as, so root 16 plus e to the power minus a half x over 2. Now they want it in this form, right? So we know, so we can just write it as, so x equals, we know it's plus or minus, so we can just write minus just because they're writing minus, is 1 over 2 square root 16 plus e to the power of minus a half x. So that's how we showed it, right? So we found the gradient of f of x at 0, right? This is how we found the gradient. So gradient of f of x at 0, because there is the normal to the curve here, and it meets the curve at point P. So to find the intersection, what we did was the line L, which we found was here, because f of x, so that's fine there. And then we simplified to find what x is. So look at part C. Use the iterative formula, x equals n plus 1, and we start with x1 equals minus 2. This is actually pretty simple. I can just do it here. So I will be, so x2 will be minus 1 over 2 square root 16 plus e to the power of 1 over 2 times negative 2. When you put this in the calculator, we will get minus 2.0229. That's this. And then it says, that's because they wanted 4 decimal places. Then it says the x coordinate of P. Basically what they want is, they want you to continue using this formula. So I'll just write, for this over here, continue until you get the same value. So if we were to find x3 now, so we do the same thing, minus 1 over 2 square root 16 plus e to the power of minus a half, and to the power of times by minus 2.0229 equals minus 2.0226. Now if we were to substitute it again, right, I'll do it again. So this will be x4 equals minus a half 16 plus e to the power of a half 2.0226. You still get the same answer, minus 2.0226. So the x coordinate of P is minus 2.0226, because when it's consistent, this is the answer we get all the time. So we can write, so x coordinate of P is minus 2.0229, and that is part II. So we just highlight this part I, and then let's move on to question number 10, which is the last question. Alright, so as it says, figure 4 shows a sketch of a part of the curve with the equation y equals 1 plus 2 cos 2x whole squared. Show that 1 plus cos 2x whole squared equals p plus q cos 2x plus r cos 4x. So you can see over here there are no squared values, so we will have to use an identity later. So let's do that. These ones are pretty long, but they're only worth so much. So let's expand this. Squared, so 1 plus 2 cos 2x. This is equal to, so 1 plus 2 cos 2x plus 2 cos 2x plus 4 cos squared 2x. This is 1 plus 4 cos 2x plus 4 cos squared 2x. Now, we need to use an identity to get rid of this cos squared. The only identity that comes to mind is the cos 2x one, right? Now, if you remember, we know that cos 2x is what? This is cos squared x minus sine squared x, right? And then if we want to only get the cos, right, only get the cos, that will be so cos squared x, we know this is same thing as 1 minus cos squared x. So cos 2x equals, this will be 1 plus so cos and cos will be plus, will be 2 cos squared x, right? So in this case, you can see we have 2x here. So let's look at our situation here, and we can say that this, because it's 2x, we can write, so let's write, so cos 4x would be 1 plus 2 cos squared 2x. And now we have 4 of them, so let's make 2 cos squared x. So cos 4x minus 1 would be 2 cos squared 2x, and we want 4, so let's just multiply everything by 2. So that will be 2 cos 4x minus 2 is equivalent to 4 cos squared 2x, and then we can just substitute this into this. So that's now equivalent to 1 plus 4 cos 2x plus, is it minus 1 or plus 1? Did I make a mistake? Yes, so this over here should have been minus 1. So consequently, this is minus 1 and this is plus 1. This is plus 2. Alright, so this will now be, so 2 cos 4x plus 2. So final answer is 3 plus 4 cos 2x plus 2 cos 4x. Alright, so we have done that. So that's our final answer. We can just highlight this. Alright, so now what? They're telling you that the region, telling you that the curve touches the positive axis 2 times, so one here and one here, so when x equals a. So we need to find the area for the shaded region, which is here to here. But for that, we need to find what? We need to find what a is, right? It's actually pretty simple. All we have to do is first equate it to 0. We can just do, so y equals 0, right? So that will be 1 plus 2 cos 2x squared equals 0. So that will just be 1 plus 2 cos 2x equals 0. So that will be 2 cos 2x equals negative 1. So cos 2x will be negative 1 over 2. Okay, so now we know that. So now let's find the solution to that, right? So that would be, just do it around here. So that will be 2x equals cos inverse of negative a half, which is 2 pi over 3. That will be the first part, one time when it touches the x-axis. Now we want the second time, that's 4 pi over 3. So x is equal to pi over 3 and 2 pi over 3. And this is the one we care about because this is the second time it touches. So this over here is 2 pi over 3. This is the second time it touches. So our final answer will be, so our final limit, actually, not the, that will be 2 pi over 3. Let's move on. So that's our limit. So now it's pretty easy. Part B here. So all we have to do is y dx. So 2 pi over 3, 0. We know y can also be written as this over here. This is much simpler to integrate, so we can just write it here. So 3 plus 4 cos 2x plus 2 cos 4x. So let's do that. So 2 pi over 3, 0. And then this will be 3 plus 4 cos 2x plus 2 cos 4x dx. Okay, so that's pretty simple. Let's integrate this. So 3 just becomes 3x and cos becomes sine. So this will be plus 4 cos, no, 4 sine 2x. And because it's 2x, we divide by 2. Plus same thing here. So 2 sine 4x and we divide by 4. The limits are 2 pi over 3 and 0. So let's now, so that will be 3 times 2 pi over 3 plus 2 sine. So 2 times 2 pi over 3 plus a half sine 4 times 2 pi over 3, and this all take away, so we know this is 0. We know that this would be 0 when substituted. This will also be 0, and this will also be 0. So this will be 0. So when we simplify all this, we will get, so let's simplify this. So this will be 2 pi, and then this one 2 sine x. So this would be minus root 3, and then a half sine of 8 pi over 3. That'll be plus root 3 over 4. So total area, or this area, will be 2 pi minus 3 root 3 over 4 units squared. So that is our final answer. That is the end of the paper. That is the end of the paper. So the end. Please be sure to like, subscribe, and share with people that you think may benefit from this video. And please join the Discord for more content and just other people helping each other out and building community. Thank you for listening. I'll see you next time.